everybody, and welcome to another From the Desk of Lady Ada. It's me, Lady Ada, and this is my desk, and we're going to do some electronics tonight. That's what we do here every night. Well, except the last night when I was playing Fallout 4, and then I was trying to like do the key locking thing with bobby pins. But today we're actually going to do some EagleCAD. I'm going to start sketching out the ideas of a Metro, like an Arduino compatible, basically, that uses the M0 chip, the ATSAM-D21G18. I kind of pitched this idea to Massimo a couple weeks ago, and I was like, hey, let's make a version of the Metro it's basically the M0 or the Arduino Zero, but low cost. And he's like, okay, yeah, like, why don't you design something and we'll take a look at it. So I kind of have to get around to it because I said I would. So that's what we're going to do. And this is kind of what I'm going to base it off of. And I'm going to think of a couple ideas of how I'm going to lay it out. I'm not going to finish it tonight because I can't finish it in a half an hour. I'm not that fast. But at least we'll get started. All right, do this thing. Let's go to computer. All right, I got my EagleCAD. So I'm in Metro land, and let's make a new version. Actually, I'll go back here. And I'll just call this Metro M0 for now. And I'm not sure. I think I'm going to go with basically the through hole with the LDL. I was thinking about a buck converter, and I'm still not sure whether I want to do that or not. Drag that in there. Okay, just rename the file. Hey, it's a cat. Hey, cat. Yo. Cat's hanging out. Yeah, he's just chill. Well, he's just chilling. So this is the M0 as it is, sorry, the Metro as it is now. And it's basically just, a basic Arduino compatible. So we're going to gut a bunch of this and see if we can kind of shove in the M0, because we're going to keep a lot of things. Some things we're going to keep. We're going to keep the micro USB jack. We're going to keep the reset switch. We're going to keep all the headers. We're going to keep the power switch circuitry. And we're going to keep the LDO and the on-off switch. And we're going to kind of keep like all of this, and we're going to get rid of this, the USB serial converter, and this, the chip and crystal. So this stuff stays. Congratulations, you get to stay. This stuff stays. IO level detection doesn't make any sense anymore because there's no 5-volt IO. So well, I'll leave this for now. Take care of it. The clock LED, the SCK pin 13 LED is actually going to change to be digital 13. Power LED is the same. Power supply is fine. Basically, it's just a Schottky diode with an on-off switch capability, which I kind of like. Power switch supply selection is the same. I don't need this, though. Later. And I don't need this. Actually, I kind of don't really need any of this. I will keep, I don't think I need the resistors. I'll just kind of gut this. Move this up here, move this down here. The M0 does not use, it has these resistors in place, so I'll just remove those as well. I'll keep the fuse. Keep that D minus D plus. Get rid of this. These LEDs I'm going to keep. I'm going to power them from 5 volts because this is going to be the RX and TX lines, which are now controlled by the processor chip because it's built-in USB. And this is going to be RX LED. This is going to be TX LED. And then I'll kind of move this. I'll kind of move this over here. And I should totally change this. This is D13. Okay, so that's good. Next up, I want to keep these headers, but I'm just gonna, well, no. Click this thing, delete that. And I'm deleting this crystal too. And this whole reset enable stuff just doesn't, it's not even part of this. Reset. I don't remember if I need this for reset. I'll keep this. I gotta eventually get rid of the, I don't need this anymore because this is just a plain RX-TX. Okay, I'm gonna make myself some room. Gonna pull this up. I'll leave this over here. There's lots of room for blah, blah, blah. Okay, so let's go back to dev boards. And let's grab what I know is good, which is my Feather Zero basic design, which like is pretty solid. I got this layout very satisfactory. Yes, the D plus, D minus lines go straight in. VBAT, I don't need that. Reset does not have a pull-up on it. I think it just has a better reset circuit. Okay. And then paste this in here. Now I'm going to make some more room. I'm going to allow put that back. Going to stick this here. Stick Okay. And then get rid of this. Just bring this over. Okay. Whew. Got a lot more room now. Okay, I got space now. So it looks like I don't need this diode. Oh, you know what? That's probably to protect against the high pulse of the DTR line, because like when it's capacitively coupled, so when it switches low, it spikes low, but when it switches high, it actually can spike up to 10 volts. So it's probably just to protect it from actually going above 5. And then this should be reset. And then this is actually not, this is not cart, this should be separated. Get rid of this. Yeah, ironically the reset button's on here, but it doesn't actually use this to program it. It uses SWD. Okay, next up. I know for sure that this should be 3. And while I'm at it, this should be 5. Because I think that's standard. This should be 3.3. Sure this is the exact same type. Yeah, these are all tied together. Probably change VDDA to AVCC later. VDD core is 1.8. We don't do anything with that. 5 volts, 5 volts, 5 volts. Actually, you know, this should be 3. Because it's controlled by GPIO. Okay, so this, I actually have to bring this out. This is called RX-LED. And bring this out. Properly name this TX LED, and it ties them. And then go through, name these properly. Sure, these are called something else different. Yeah, these are called A0, A1, A2, 3, 4, no, actually, yeah, it's fine. It says connect, but it's actually not connecting them, it's renaming them. Okay, AREF, and then this is SDA, SCL. Okay, let's see what needs to be connected. D12. Oh, did I miss that one? I missed that one. Oops. Sorry about that. Okay. This should be bang reset, USB VCC. Oh, this is this deleted thing here. Right, I'm gonna just get rid of this whole thing. Not used, cannot run on 5 volts. Okay, with this, I gotta actually fix this in a bit because AVCC doesn't exist. Ground A, that's fine. VDDA, this is where I'm going to change this. I'm going to delete this, bring this over. And then this is going to be my little filter for the analog VCC. You can get like a nice clean line in. Sorry. It's this way. So you get your 3.3 volt, which is pretty clean already. It goes through a ferrite, there's a little filter, and goes to your analog in. That's kind of nice. Okay, VDDA, VCC, that's fine. VDD core is fine. I mean, this maybe VDD core, make it happier. VDD in is 3 volts, that's fine. VDD IO is 3 volts, that's fine. That's fine. It's fine. It's fine. No value. This actually is a EBQQ. 6mm. Test point. I'm actually going to, oh, yeah, this is uninvoked. All right, this wants me to, this is a dual op amp. So, if you're not using your op amp, just tie the 2 inputs to ground. There you go. It's fine. RX LED. Give it a nice visual connection. There you go. Okay, so that's that. So that at least works. Now let's take a look. Okay, so we're gonna need to reroute most of this, but you know, this kind of goes here-ish. You know, for the most part, like, not a lot changed. Like, that's emptier, but, you know, we'll drag these D plus, D minus lines down. I'm not too worried about that. Usually, this isn't a high-speed USB device anyways. Okay, I'm going to change the packages on these pasted things to be 805, no outline. I'm going to keep this too. 0805. No need for 603s in this design. This is huge. And then for the crystal, I've got in my micro builder library, a crystal that is larger and less expensive. Not that one. It's the same crystal used in the NRF 8001. Let's see what this part number is called. Is crystal... Crystal 8x38. Okay. So, I just want to swap this out. These crystals are small. The large ones are like 30 cents less, which actually kind of adds up. Crystal. There you go. Okay, I'll just delete this and swap this in. Okay. Yay, slightly bigger crystal. 32.768 kilohertz, which is synthesized inside the chip to make higher frequencies. Okay, so that's a good start. We should also, we have space, so we can, well, I don't know, I gotta decide whether I want to put an SWD pin in on this. I mean, I guess I could. I think the, connector's a little expensive. Maybe for now I'll just keep these pads. I'll figure out what I want to do later with them. Okay, So I'll clean this up a little later. I'm not ready to route yet. I got the LEDs, that's good, on LED, on off switch, same power system. What's neat is actually, like, because we don't have a USB serial converter chip, the bill of materials is actually less now. Because even though I've got this Cortex chip, it actually costs less than the combination of the Atmega 328 and the USB serial converter chip. Okay, but I want to add the USB host swap control, power control. So, kind of neaten this up. So USB host enable is an interesting pin that will let you, instead of having it powered by USB, it can power USB device, and you can do USB on the go, which means I also have to change around this ID pin. So, the thing is, I don't know how the hell I'm going to test that, because I don't think there's any example code for it. So let's go back, and I downloaded earlier the M0 reference design. Oh, so I gotta uncompress it. Okay. So this one uses a buck converter, which I don't do. I could add that, would add about 80 cents to the bill of materials. So I'm not so sure I want to do that. I might stick with a linear regular for now. But this is where the interesting action is. So here you see USB host enable goes through here and has a 1 gate enable. So if basically this turns it into a transistor. Oh, it uses ID. Okay, I have to think about how this works. So you've got the USB power, and normally this powers the 5-volt line. You can see it actually, this even has the body diode of the MOSFET, just basically passes it through. But then I guess you can turn it on, and then it will back power it, and it will do that. What is power in? Where does this go? Let's turn off every single layer. Okay. It's because I'm curious about where this comes from. Oh, that comes from the positive DC power. So if it's plugged into DC, then this will enable this. Wait, this has to be high. So this makes it, 4.5 volts or so. R3, okay, so it says do not place. I'm assuming this means don't place. Okay, so you have a little thing here. This has to go low to enable the output. If it's high, then this is open. So this goes low, this pulls low. This pulls low, this turns this on, and then it backflows. Okay. Interesting. All right, I'm down with it. I will. Okay, so I should grab Wow, what is this? Is this a drain resistor? It's just kind of hanging out between USB VCC and ground. Kind of weird. All right. So let's grab. Oh, and then this is connected to the ID pin. I see. Okay. Oh, dude. Okay. They love using like all sorts of class thickness stuff. Might put that there. And this connects to the ID pin, which is, I think, let's see, USB on the go, ID pin. I think the ID pin, yeah, normally it's not even used. Yeah. I see. The ID pin is connected to ground in the mini A plug. The OT device is personal ground IP pin. Okay. So this is floating. This has to float for this to even occur, I guess. And then this connects to, where was I? To USB VCC. Okay, so just type this right in. The question is if I can reuse this transistor. So let's look up what this this FET is. Now this says 20 volt 3.5 amp. Let's compare these two. See if I can just use one. It's always better if you can reuse one transistor twice. So yeah, they have a 20 volt 3.5 amp with 55 milliohms. And then what I'm using, actually, I'm not gonna keep this open, later. And then this is also not being used, later. And then I'm done with this. And then I'm using over here the DMG 3415. So the one I've got is 39 milliohms, and the one they're using is 55 milliohms. There's 8 cents, minus 15. I guess that's okay. But I need mine to be able to handle the higher gate source voltage, so I can just use mine. It's a little more expensive, but I think that's okay. So. Let's change this part number to that. Let's get rid of this. This is SC. I actually have a similar part that's in SOC 125. This one, yeah. That's kind of ugly. Do we have any? They're not ugly. Oh, this is fine. I'll just rename it. Okay, 74 LVC. 1G135, and then the rest is just the packaging code. Remove that. I want SOT 23.5 rather than SC70, because that's what I have stocked. Okay, I'm going to change the package on these to be, swap this for 0805. Resistor. Yeah, I'm actually going to just change packages and I'm done. Then I just have to route. Not today, though. Nope. Change, 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 change. And then this, power in, connects to, oh. I don't really want it to connect there, though. I want it to connect to here, VN. So I'm going to change this to be, oops, use rename instead. I think that's better because I want it after the on-off switch and after the Schottky diode. I think that's fine. I mean, like, this can handle 1 amp. And then this will have to max source 1 amp. Okay, so. Oh, right, I don't want that. Oh, I got to invoke the power lines for this. E. There you go. Missing junction. All right, all the junctions. Only one pin. Oh, USB host N. And name this. Okay, hold on. This is named PA28. There you go. Now they're tied. Yeah, that's cool, that's cool. Oh. Ah, okay. Walking out. Okay. Whew. All right, so I can stick this. Oh, so what I'm going to do is I'm going to stick this over here, and then next time I will route this. I'll place these very nicely into like this little spot here. And then I'll route these lines. Maybe I'll change this to a QFP and then send out a proto. That was my board design.
All right.
Yay! I got started. Largest thing on this board is a crystal. But I think it's actually just a cylindrical crystals and they epoxy it and that's it. So you want a cheap crystal, go that way. Definitely less, I mean, this is so bulky. Like, these capacitors are huge. And all this other stuff is so big that it's not a big deal. Okay. Want to turn off the streamings?
Yep.
Yeah, interesting. Yeah, this pulls up high. To enable the host, this pulls low, and then this feeds the power back. Oh, that's kind of interesting. All right.
I noticed your desk is lady. Oh, I said we have the cat.
Oh yeah. Well,
I said we were up.
if the cat's around.
He just stay over here. He's not
Okay.
gonna like this at all.
Nope.
Hey, dude.
Oh, he was so sleepy.
Yeah. Not gonna be happy cat.
Okay. Bring the cat over here.
Be
Yeah.
careful, because
I
there's
know.
always a...
He's clawsy.
Yeah.
He's got sharp edges. Okay.
All right. All right.
Okay.
See you later.